Well said. Okay. So today's is not very easy. I apologize for that. But if you follow along, it's not too bad. It's just kind of tedious. Okay. I'm going to kind of jump down here and skip all that wording for a minute. And find all the zeros. What's the easiest way to find the zeros of a polynomial? To factor it and set the parentheses equal to 0, right? Yes, somebody say yes? Yes. Okay, good. So usually we would do the snowflake, or we would use grouping, and then we would set those parentheses equal to 0, and that's how we would come up with our roots or zeros, or what all are they called? Roots, zeros, solutions. But I have a problem here. I see 5 terms. That's not snowflake. It's not even grouping. So in the past, I've said, oh, here's a factor of it. You know, x plus 2 is a factor. And so you would be like, okay, I'll take x plus 2, set it equal to 0, get that negative 2, and I'll start dividing it down, right? I don't even give you that here. So I have to figure out, how can I get those zeros if I can't factor this using any of the methods I know? That's where this whole thing called the rational root theorem comes in. Okay? So here comes the rational root theorem. We start off by identifying the factors of the constant. What's the constant in this polynomial?
Negative 24.
Negative 24. So what are the factors of negative 24?
Negative
1. Plus or minus 1, 2, 3, 4, 6, 8, 12, and 24, right? Then I need to identify the factors of the leading coefficient. What is the leading coefficient? 1. I like 1 because it only has the factors of 1 and negative 1. Now, that's not my list of possible zeros. What I have to do is I'll draw a little line there. I have to set up some fractions. In other words, I have to take each one of these numbers on the top and put it over the number on the bottom. Now, thankfully, the number on the bottom is 1, right? It's not always going to be 1. It just happens to be 1 because my leading coefficient is 1. So 1 over 1 gives me 1. 2 over 1 gives me 2. 3 over 1. So this one's a nice, easy one. It's just going to be the same list, right? Plus or minus 12, plus or minus 24. So what I have come up with now is a list of possible roots or zeros. Okay? How many numbers are on this list?
8.
There are not 8 numbers on this list.
Oh, 16.
16 numbers, because there's the positive and the negative of each of those, right? Are all of these going to be answers?
No.
No. How do you know?
It says all possible.
Because it says all possible. And also because this is a 4th degree equation, which means it's going to have how many answers? 4. So clearly all 16 can't work out for me. So what I could do at this point is I could start with positive 1, do my synthetic division with positive 1 in my box, and see if I get a remainder of 0. Because if I get a remainder of 0, then I found an answer. If I don't, then maybe I would try negative 1 and see if I get a remainder of 0. That's 16 numbers to work through, isn't it? So let's see if we can be a little bit more strategic so that we're not just doing a bunch of division haphazardly, okay? Granted, 16 numbers is a lot better than every number in the planet, right? But it's still a lot of numbers. So when we have a list that's that long, I'm going to provide you with a graph because, I don't know if you remember the other day when I identified roots and zeros are also called solutions. They're also called x-intercepts. So what is providing you a graph with? A graph do for you? It allows you to actually see the x-intercepts. So this graph is very difficult to read. I apologize for that. But It's going to go down something like that. It'll come up here. It's going to curve. And then down here. Now, we didn't include all of those parts with it because we're really only concerned with the x-axis and the intercepts there, right? So how many x-intercepts do you see?
4.
4. I like 4 x-intercepts because that means that all 4 of my answers are going to be nice numbers. Or are going to be real numbers, I should say. So what's hard to read here is the markings on the x-axis. This marking right here is 4. And this marking right here, which is not a 0, but it's between two of them, is -2. So knowing what the graph looks like, what numbers on this list would I not really want to try? 24, 12, 8, 6. I don't even think I'd want to try 4. Because it looks like they're all smaller than 4, right? So I've just taken my list of possibilities and I've cut it down to 6 numbers. That's a lot better, right? Even further though, let's guess what some of these are. What number does that look like it could be?
3. 2.
It looks like it's exactly halfway, doesn't it?
Yeah.
So let's try 2 because it's on my list of possibilities and that looks like it could be 2. Now, if I get a remainder of 0, yes, that's crossing exactly at 2. If I don't get a remainder of 0, that could be crossing at 1.9, it could be crossing at 2.1, it's not exactly 2. So let's see what happens. What are my numbers across going to be? 1, 6, 3, -26, and -24. So let's do our synthetic division. 1 times 2 is 2, 6 and 2 is 8. 2 times 8 is 16. 3 and 16 is 19. What's 2 times 19? 38. That's 12. 2 times 12 is 24. Yay! That is crossing exactly at 2. So, if they're asking me to find all the zeros, I'm going to make a little box here for all my zeros to be listed in. And the first 0 is 2. Okay. How many more answers am I looking for?
3.
3, because I already have 1. I'm looking for 3 more. Now, I just took a 4th degree equation and I turned it into a what? 3rd degree equation. So I have 1x to the 3rd plus 8x to the 2nd plus 19x plus 12. So at this point, I do know one way I could factor that using what? Grouping. Let's see what grouping would do for us. I would take out x squared, x plus 8. Those two don't have anything in common. What do you notice? Those don't match, do they? So grouping is not going to help me here, unfortunately. Which means that I'm going to come back to my picture and pick another number. What number do you think I could pick? That guy right there. Looks like -1. Let's check it. So let's do -1 as my box number. And what are the numbers I'm going to put across? Am I going to put the numbers, the coefficients from my x to the 4th? No, I'm going to put my coefficients from my x to the 3rd because I've already brought it down 1 degree. So 1, 8, 19, and 12. And let's see if we get that remainder of 0. -1, 7, -7, 12, -12, 0. I got a remainder of 0. So what does that mean? -1 is also an answer. Okay? Got 2 of them. Went from an x to the 4th down to an x to the 3rd, and now I'm at a what?
X squared.
X to the 2nd. So let's think about this for a minute. X to the 2nd plus 7x plus 12. A 2nd degree equation. I could go back to the picture and try another number and keep going that way. Or I could snowflake at this point because now I'm down to a degree that I know how to factor. So let's try snowflaking this last batch. 12 and 7. What are two numbers that multiply to 12 and add to 7? 4 and 3. So what would these be? X plus 4 and x plus 3. What are the two answers here? Negative 4 and negative 3. Negative 4 and negative 3. Does it look like these two values on this graph could be negative 4 and negative 3? Yes. Okay. If this is negative 2, that's probably negative 4, and then halfway would be negative 3. So, is it tedious? Yes. But it's what we have to do until we can bring something down to a degree that we know how to factor using other methods. Okay? So-so? A little funky. Okay. These instructions are slightly different. What are these instructions? Write the fully factored form. What does that mean? Is my answer going to look like this one up here? What's my answer going to look like? It's going to have parentheses, isn't it? It's going to be the sets of parentheses that equal that. Do you notice that something is missing from this one that the other one had? The what?
X squared.
Okay, in addition to x squared, there's no picture. There's no graph. Now, on your homework, this website right here, I think they have an app too, desmos.com. You can go and graph anything on there. You just go in there, type in the equation, and it will show you a graph. So if you want to look at the ones on your homework, go for it. When we get to a test or a quiz, if I don't give you a graph, that means your list of possible zeros is a short list. I wouldn't give you something with no graph with 16 numbers to try. But maybe with 4 or 6, I might leave it with no graph. Okay? Which is what we have here. So let's come up with our list of possibilities, starting off by the factors of the constant. What's my constant?
1.
No.
27.
27. Plus or minus 1, 3, 9, 27. Right? What about the leading coefficient?
1.
Is still just 1. So if I set up my fractions, 1 over 1 is 1. 3 over 1 is 3. 9 over 1 is 9. And 27 over 1 is 27. So the possible zeros are in that set of 8 numbers. Now, when I have you doing this on your own, most likely positive 1 or negative 1 will be one of the answers. Because I'm not going to make you do 6 synthetic divisions before you get to an answer. Most likely positive 1 or negative 1 will work. If not, the second term you'll have something that works for you. So what am I going to do? I'm just going to start going through the list. That's the only thing I can do. So I'm going to start with positive 1. If I get a remainder of 0, fantastic, I'm on my way. If I don't get a remainder of 0, then what should I do? Try negative 1. Okay. What are my numbers across the top? 1, negative 1, 0, 27, negative 27. We have to remember those placeholders. And if you're going to make a mistake anywhere, it's going to be there. Let's bring down that 1. 1 times 1 is 1, 0, 0, 0, 0, 27, 27, 0. I got a lot of zeros there, but the most important one is that remainder is 0. So did I just find an answer?
Yeah.
I did. But they're asking for the answer in a different way. They don't just want the answers. They want the parentheses. So if x equals 1 as an answer, think backwards for a minute with me. What did the parentheses look like that it came from? X minus 1, because you had to add 1 to that other side to make it positive, right? So whenever you get an answer, the parentheses version of it has the opposite sign. Does that kind of make sense? Okay. What's the rest of it? I had x to the 4th. Now I have x to the 3rd. 0x squared. 0x plus 27. And let's see if I can go any further. I don't need to worry about the x minus 1. That guy's done. But that guy, I think, can go further. Should I continue on down my list, or do I know something else I can do? That's a sum of cubes, isn't it? So I could continue on down my list if I wanted to, or I could just refer back to my sum of cubes formula. This one I'm going to use x and 3 as my two numbers. So what do I get? X plus 3 would be in my first parentheses. Then what? X squared minus 3x plus 9. And I will tell you that after you have used your sum or difference of cubes, you're done. You cannot break that x squared down any further. You can sit there and stare at a snowflake as long as you want, but you're never going to find numbers that will make it work out. Okay, so this is factored form. These are the actual answers you get from factored form. Those would be your zeros or your roots. So? Okay, turn the page. So, on the front side, the leading coefficient was always 1. Now I'm going to show you what you have to do if the leading coefficient is not 1. Okay? It's the same process, your just list of possibilities grows a little bit. So if I look right here, what is my constant? What's my constant? 8. So the factors of the constant would be 1, 2, 4, and 8, correct? Then I need the factors of my leading coefficient. What's my leading coefficient? 4. So let's see, 1, 2, and 4. I need to set up my fractions to get my list of possibilities. But I have 3 denominators. What the heck do I do with 3 denominators? Well, I treat it as 3 different sets of numbers. For example, if I were to cover up the 2 and the 4 and just look at the 1 on the bottom, if I set up my fractions with a 1 on the denominator, I have 1, 2, 4, 8, right? 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, 8 over 1 is 8. That's the first part of my list. So 1, 2, 4, 8. Now let's ignore, now that we've done that 1 denominator, now let's set them up over 2. 1 over 2 is 1/2. 2 over 2, what is 2 over 2? 1, which is already on my list, so I don't need to add anything else. 4 over 2 is 2, which is on my list. And 8 over 2 is 4, which is on my list. So the only new one added there was the 1/2. Now let's put them all over that third denominator there. 1 over 4, got to add that one because it's not on my list yet. 2 over 4, what's 2 over 4? 1/2, and it's already on my list. 4 over 4, 1. 8 over 4, 2. This is my list of possibilities. So when your leading coefficient is not 1, you're going to have some fractions on your list. All right? Now that problem, it didn't want me to do anything except for come up with that list. Now let's look at the next one. I want you to take a minute. Start this one off by trying to come up with the list of possible zeros. Okay? So list your factors of your constant, your leading coefficient, and see if you can come up with the list, the complete list of possible zeros. So there's my constant factors. Leading coefficient. One, 2, 3, and 6. Yeah? So, starting off with my fractions. 1 over 1 is 1. 3 over 1,
3,
9 over 1.
9.
Done with that first denominator. Now let's put them over 2. 1 over 2,
1 half.
3 halves, 9 halves. Yeah? All over 3. So 1/3. 3 over 3 is 1, which is on my list. 9 over 3 is 3, which is on my list. And then finally 6. So plus or minus 1 over 6. And then 3 over 6 is what? 1 half, which is on my list. And what's 9 over 6?
3.
3 halves, which is on my list. This is my complete list of potential zeros. Possible zeros. How many numbers are on that list?
2, 3, 4, 5, 16.
16, right? Positive and negative of each of those. Thankfully, they've given us a graph. Again, the graph is hard to read. I apologize for that. I will say these markings are -5 and +5. Now, seeing where those intercepts are, one's here, 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 and here, they're all pretty close, aren't they, to 0? Which means I'm not going to start off by checking positive or -9. Right? This one is a bit harder to check. To me, this one seems reasonable to start with because it's the closest one to 0. So let's find some of the fractions that represent a close number to 0. If I want to get close to 0, I can do -1/2 because I am on the negative side. That's not really close, that's not really close. -1/3 is pretty close, and -1/6. So this is going to be where I'm starting to see if I can find that value right there. All right? So let's see. I'm going to start off with -1/2. Yes, you can use a fraction as your box number. What are my numbers across going to be? 6, -7, -21, +21, and 9. And let's see what we got. 6 times -1/2. -3. -7, -3 is -10. -10 times -1/2. -21, 5. -16. -16 times -1/2. 21 and 8 is 29. I can tell from here it's not going to work out. How do I know? Because that's not going to multiply by 1/2 and give me a nice number to give me a remainder of 0. It's going to be -29 over 2, and it's going to give me something that's not 0, right? So -1/2 is not that point right there. So let's go on to my next one, -1/3. Same numbers across, 6, -7, -21, 21, and 9. 6, what's 6 times -1/3? -2, -9. -1/3 times -9 is 3. That's 18. 18 times, I'm sorry, -18. -18 times -1/3 is 6. 21 and 6 are 27. 27 times -1/3 is -9. Thank goodness we got a remainder of 0. Am I factoring here or am I finding all the zeros? Finding all the zeros. So, how many zeros am I looking for total? 4. -1/3 is my first one. Okay? So, what have I got left? I had a 4th degree, now I have a what? 3rd degree? 6x to the 3rd minus 9x to the 2nd minus 18x plus 27. I could try and guess one of the other intersects, or since I'm down to 4 terms, I could try grouping, right? Since a lot of these are fractions, I'm going to try grouping. 3 goes into all of them. That's absolutely right. So if I were to take, before I even do the grouping, if I were to take a 3 out, that leaves me with 2x cubed minus 3x squared minus 6x plus 9. Now I have a question. Is there an answer with this 3? Is one of my zeros going to be right here? No. If there's no letter there, there's no 0 there. I'm going to get all 3 of my remaining ones from what's inside here. So let's cut it in half. I can take out x squared. 2x minus 3 is left inside. Minus 3, and then 2x minus 3 grouping is going to work this time, isn't it? Because I got matching parentheses. So I have x squared minus 3 and 2x minus 3. So, x squared minus 3. If I set that equal to 0, I would add 3. That gets me x squared equals 3, so what do? Square root, and I get x equals plus or minus radical 3. How many answers is that? That's 2 added to the one that I had before. So I have 3 total. I just need the last one, and that's going to come from this 2x minus 3. If I set 2x minus 3 equal to 0, let's add 3. 2x equals 3, and x equals what? 3 over 2. And there's my 4 zeros. Now, I will say this. On the test, this is a lot of work. Expect a lot of points for a lot of work. Okay? It wouldn't be fair of me to make this a 2-point question. Right? So, yes, it's difficult, but also understand that that's going to be kind of point heavy when it comes to the test. Okay? Let's see. Let me talk just briefly about this guy. This guy, if I were to look at the x-intercepts, each of those x-intercepts looks a little different from the others. This one has kind of a wiggle going on. This one just cuts straight through. And this one has what I call a kiss. Goes in and kisses the x-axis and then comes back out. What that is those are examples of different multiplicities of roots. Remember multiplicities? So this right here, this little kiss, that has a multiplicity of 2. We call that a double root. This little wiggle right here has a multiplicity of 3. We call that one a triple root, or a point of inflection. The one that just goes straight through the x-axis, that's what we've been looking at. That's just a multiplicity of 1. It only happens once. But what does a multiplicity of 2 mean? Like, if my equation ends up with something like this, where I've got powers in it, what that means is, if this location, I believe it's at 2, if I were to use 2 as my box number, I would get a remainder of 0. I would bring it down a degree, bring my equation down a degree, but since it's a double root or a multiplicity of 2, I could use 2 again and bring it down even further. So it would get me a remainder of 0 twice. If I have something like this, it would get me a remainder of 0 3 times. Okay? You might not encounter that very often in ones like these, but just know that once you use a number, you don't have to throw that number off your list. If it looks like that, it could work more than once. Okay? So just be aware of that kind of in the back of your mind as you're working through it. Okay? All right. Happy studying.